Welcome everyone. We've got a past paper question on standard enthalpy changes, Hess's law and test for ions. It's from AQA Year 2, Paper 1, 2017, question 1. Black text is the question, red text provides additional information, blue text is the answer. Some points may be highlighted during the description. You may want to pause the video at various points to have a go at the question yourself. Let's get started. Here's the question. This question is about silver iodide. Define the term enthalpy of lattice formation. Definitions of standard enthalpy changes need to be memorized. Enthalpy of lattice formation is energy change when 1 mole of a solid ionic lattice is formed from its constituent gaseous ions. Other standard enthalpy changes that you need to know include enthalpy of formation, enthalpy of combustion, and enthalpy of hydration. You also need to be able to construct chemical equations that represent these standard enthalpy changes. Can you provide an equation to represent this standard enthalpy change? Here's the next part of the question. Some enthalpy change data are shown in the table. Use the data in the table to calculate the enthalpy of lattice formation of silver iodide. For this, try to construct a Hess cycle. Identify species that are common between the three equations. I've highlighted these in green and in blue. Silver ions appear in 2 equations and iodide ions appear in 2 equations. This is how I constructed the Hess cycle. To find delta H1 and delta H2, use the data from the table. It's really important to be clear when showing your working out and take extra care with directed numbers. To find the enthalpy of lattice formation, we need to use Hess's law. Enthalpy change is independent of the route taken. Delta LEH is equal to delta 2H minus delta 1H. If you're going against the direction of an arrow, you need to reverse the sign. Substitute the unknown values to get the final answer. Here's the next part of the question. A calculation of the enthalpy of lattice formation of silver iodide based on a perfect ionic model gives a smaller numerical value than the value calculated in question 1.2. Explain this difference. All ionic substances have some covalent character. Electrons will be shared to some extent. However, for 2 marks, we need to address the question very carefully. We need to say why the value is smaller. If the calculated value is smaller, the bonds holding the lattice together are stronger. Here's the next part of the question. Identify a reagent that could be used to indicate the presence of iodide ions in an aqueous solution and describe the observation made. As is often the case with A2 questions, you are expected to move between different related topics. So far, we have dealt with Year 2 standard enthalpy changes and Year 1 Hess cycles. How could this question about Year 1 tests for common ions be linked to the lattice enthalpy of silver iodide? Silver ions form precipitates with chloride, bromide, and iodide ions. The common reagent to provide the silver ions is silver nitrate. Nitric acid is often added before the silver nitrate. Nitric acid will remove any hydroxide ions or carbonate ions that will lead to false positive results. Silver chloride is white and silver bromide is cream. You could also test the identity of the silver halide by the solubility in dilute and concentrated ammonia. Thanks for watching. Take care.